Solving radical equations notes. When solving a radical equation, we use these special rules for solving. First, the radical must be alone before you apply the inverse operation. And secondly, we have to look for extraneous solutions. Remember, when you take the square root of a real number, we only want the principal square root, which cannot be negative. Let's take a look at some examples. Turn the page. Here's the first example. Example 1. Remember, step 1 is to get the radical by itself. So we want to divide both sides by 2. And we get the square root of x plus 1 equals 7. Notice the radical has been isolated. This whole thing. Okay? Second step. Now that the radical is isolated, we can now undo the square root. And so undoing the square root, the inverse operation is to square. So we're going to square both sides. If the root is 2, then the power is going to be 2. And we get x plus 1 equals 49. Step 3 is to solve. So continuing on, solving this problem, 6 plus 1 equals 48. Excuse me, x plus 1 equals 48, x equals 47. Step 4 is to check for any extraneous solutions. So what we do here is we plug in our answer, which was 47. We plug that into the equation. Excuse me, I miswrote up here. That's a 49, and that's a 48. So it's 48 plus 1. So 48 plus 1 is 9, 49. Square root of 49 is 7. 7 times 2 is 14, and that works out just fine. Okay, go ahead and you try number 2. Please pause the video. On example 2, you try. First up, that's correct. Get the radical by itself. Isolate the radical. So we're going to start off by adding 16 on both sides. And we end up with that. Now the radical is isolated. So now we can take the inverse of square root, which is to square both sides. The square cancels out the square root and leaves us with 2m minus 6 equals 256. Now we solve. Adding 6 on both sides, we get that, dividing by 2, and we get m equals 131. Check our answer. We plug 131 in for x. 2 times 131 minus 6 gives us the square root of 256 minus 16 equals 0. Square root of 256 is 16. 16 minus 16 equals 0. And yes, it does equal 0 equals 0. And that is correct. Okay, looking at example number 3. Notice, step 1 is isolate the radical. Well, the radical is already isolated. So we can skip step 1. So moving down to step 2. How do we get rid of the radical? Well, the root is 2, so we're going to square both sides. So we're going to take the square root of x plus 18 and square it. And there's a group on the other side, so we have to put parentheses around them. There's 2 terms, and square them. Okay, squaring it, we get rid of the radical, we get x plus 18 equals, and we have a binomial squared, so we're going to FOIL it. So we're going to have x times x, and the inner is going to be negative 2x, and the outer is going to be negative 2x. That's going to make negative 4x. And then negative 2 times negative 2 gives us 4. You can write that out on a separate piece of paper if you need to and FOIL it. X minus 2 times x minus 2. Alright, so what type of equation do we have here? Correct, it's quadratic. And remember how to solve a quadratic? Yes, we set the equation equal to 0. So we're going to subtract the x, subtract the 18. So we're going to have x squared. If we subtract the x, we're going to get minus 5x. If we subtract the 18, we're going to get negative 14. And we're going to set that equal to 0. Okay, now we're continuing to solve. This is step 3, solving. Since it's quadratic, we can go ahead and solve by factoring. That would be what I would try first of all. So x times x is x squared. So two numbers that multiply to give us negative 14 and add to give us negative 5, that's going to be negative 7 and positive 2. Then we need to solve each one. So x minus 7 equals 0. X plus 2 equals 0. Remember, that is the zero product property. So one solution is x equals 7. The other solution is x equals negative 2. So here it says we have two solutions. Now let's check them. So the first solution, 7. If we plug that into the original equation, okay, we get the square root of 7 plus 18 is equal to 7 minus 2. So 7 plus 18 is 25. Square root of 25 is 5. Equals 5. Check. So x equals 7 is a good answer. Let's plug in negative 2. So we have negative 2 plus 18 equals negative 2 minus 2. So the square root of 16 equals negative 4. And remember, when we take the square root of a number, we're only looking for the positive answer, not the negative answer. So x equals negative 2 is extraneous. Extraneous. It is an extraneous solution. So we do not want it. X equals 7. Okay, you try the next one. Okay, example 4. Let's see how you did. Should have squared both sides. Set the equation equal to 0. Factored it. Found your two solutions. X equals 5, negative 5, and x equals 1. And then checked each one. When you check negative 5, you should have gotten the square root of 4 equals negative 2, and the answer cannot be negative, so this is an extraneous solution. So we do not count it. And checking the other one, plugging 1 in, we get the square root of 16 equals 4, and that's correct. So the only solution we're going to count here is x equals 1. All right, moving on to the next page. Notice the difference here. The difference here is we have a root of 3. So let's see how we handle that. First step, isolate. So we're going to start by adding 20 on both sides. So we're going to add 20 on both sides, and then we're going to divide by 5. And we're going to get x plus square root of x plus 2 equals, if we add the 20, we get 20 over here. And then 20 divided by 5 is 4. And by the way, that is the third root. The third root. So how do we cancel out a third root? Well, we canceled out a square root by squaring it. Take it to the second power. Third root, we're going to cube it. So that cancels the third root and the third power cancel out. We get, let's move down here. I think I'm in the wrong section. So let's move down here. Let's move down here. We get x plus 2 equals 4 cubed. 4 times 4 is 16. 16 times 4 is 64. And subtract 2 on both sides. We get x equals 62. Okay, once we find our answer here, x equals 62, we plug it back in. 62 plus 2 is 64. The cube root of 64 is 4. So we have 5 times 4 minus 20 equals 0. So that's going to be 20 minus 20, which is 0, equals 0. That checks out. So this is an answer. All right, go ahead and try example 3. Okay, going through this quickly. I started off by subtracting 6 on both sides to isolate the radical. So we end up with this. Then I do the inverse of the third root, which is the third power. So I take the third power of both sides. I end up with y minus 4 equals 27. Add 4 on both sides. We get y equals 31. Okay, plugging the 31 in. 31 minus 4 is 27. The cube root of 27 is 3. 3 plus 6 is 9. And it checks out. So y equals 31. No problem. Okay, let's look at this last example here. Here we have 3x minus 1 to the 1/5 power equals 2. Well, we want to isolate the radical. What radical? Remember, 1/5 power. 1 is the power, 5 is the root. So we could rewrite this as the 5th root of 3x minus 1. Remember that? Well, the radical is isolated, so what we can do now is we can apply the inverse operation. Well, what's the inverse of the 5th root? Correct, the 5th power. So we're going to have the 5th root of 3x minus 1 raised to the 5th power, so that it will cancel out. Equals 2 to the 5th power. So we get 3x minus 1 equals 2 to the 5th power, which I believe is 32. Okay, going down here and solving, we're going to go ahead and add 1 on both sides. So we get 33x equals 33. Divide by 3. X equals 11. Okay, plugging 11 in to check our solution, we're going to have 3 times 11 minus 1, and that's the 5th root of that. Does that equal 2? Well, let's see.